Well, hey. Welcome back. It's good to have you with me. We're going to talk a little bit today about looking at equations and lines that are perpendicular. So let's take a look. Let's just get started. I've got two equations here. In order to plot them, we need some solutions. So I'm going to make a t-chart over here. So I'm going to go x, y, and basically I'm going to do some substitution. So I'm going to plug in 0 for x. So 2 times 0 is 0. I'm going to do 1 for x, so 1 times 2 is 2. And I will do then also a negative number. Negative 1 times 2 is negative 2. Check. I'm going to do this one here. I'm going to do a t-chart on this one because it's going to allow me to get some coordinates going. So I'm going to do 0. Negative 1/2 times 0 is 0. Now the next number I'm going to use, I can use any number I want. I can use 1, 7, 36, 72, it doesn't matter. But I'm going to pick something smart. I'm going to pay attention to what I'm doing because I need to take half of that number. So that's 1/2 times x. So I'm going to pick a nice number that when I do the half of it, it's reasonable. Like for instance, 2. Half of 2 is 1, but I see that it's negative here, so negative times a positive will be negative. I'm going to use negative 2 as well. So half of 2 is 1, but a negative times a negative will be positive. Okay, so now that I got my two numbers here, I can go ahead and plot them. So I'm going to plot this guy right here. So I'm going to plot at 0, 0, so right in the origin. I'm going to go to 1, 2, and I'm going to go to negative 1, negative 2. And I can see a pattern where it kind of like goes over 1 and up 2, so I'm going to follow that pattern, over 1, up 2, and make a dot. Over 1 and up 2, over 1, up 2, just so I can get my line down. There we go. There. Now it will be a straight line because I have a coefficient, a rate of change. Let me get that. Because my line represents a solution, I'm going to make sure it's right on the intersections where it fits it. So be careful, there's a little bit of precision on here. Make sure you are plotting accurately. Oop, this one goes to the origin as well, 0, 0, and it goes through 2, negative 1, and negative 2, 1. So I can see my pattern here. It's like over 2, up 1, over 2, up 1, down 1, over 2, down 1, over 2. There's my pattern. And whoa, that's a tough line, but it fixes itself. So great. There we go. Now these lines are perpendicular. Makes a 90-degree angle. And if you look at the pattern of the relationship here, they both have, if I look at the coefficient here, if you notice something about them, let's just pay attention to that. And then we're going to do a couple more and see if you can find some patterns. Okay, so there's that one. All right, let's try this one out. Pair 2, I'm going to do a t-chart again, x, y. So for this one, if x is 0, y is 0. If x is 1, y is 4, because 1 times 4 is 4. If x is negative 1, y is going to be negative 4. I'm going to do this one. Now 0.25 is actually 1/4, so I'm going to pick numbers that are nice when you put them into fourths. So if x is 0, y is 0. If x is, I know, I can use 1, 2, 3, 4, but here's what I'm going to do. I'm going to use 4 because I know 1/4 of 4 is 1, and a negative times a positive will be negative. I'm going to also use negative 4 because 1/4 of 4 is 1, and then a negative times a negative will be positive. So I'm going to plot these out. Let's put this guy first. 0, 0, 1, 4, negative 1, negative 4. Wow, this has got a pretty good jump to it, right? So I'm going to connect my lines, and then I'm going to extend them. Nice, look at that. There we go. Check that. Next one. Let's pop this guy. 0, 0 goes to the origin. Not everything goes to the origin, just, things move around as you have y-intercepts. Draw that line. Extend them out. Ooh, there we go. Nice. Ding, ding. Ding, 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 ding. There we go. They are parallel. Oh, no, they're not parallel. They're perpendicular. Parallel would be like if they go like this. That's not what happened. These are perpendicular. So let's look at our coefficients again. Like, what's up with that? So if there's a pattern. So if you notice, a couple things unique about it is in order for these things to become parallel, no, perpendicular, holy moly, keep getting that wrong. In order for them to be perpendicular, I have to notice the coefficients. Now notice on this one, I have the number, and this one here is its opposite. It's two things. It's its opposite, and it's its reciprocal, or its flip over number of it, because there's 4, and then negative 0.25 is negative 1/4. Okay, so it's its opposite. That happened up here too. It's opposite and it's reciprocal. So notice this guy is 2, this guy is negative, opposite, and it's 1/2. The reciprocal is basically flipping the number around. So this 2 is actually 2/1, and its reciprocal is 1/2. This reciprocal is 4/1. That's what its number is, and its reciprocal is 1/4. So you're looking for, if you see two equations and one number, let's look at this guy right here. So I'm just going to look at the coefficient. There's -3, and if the other one has a rate or a slope that is opposite, so this one's negative, this one's positive, and it's reciprocal. So I can already tell that these two right here in this pair should end up being perpendicular when I graph them out. Yep. So why don't you go ahead and graph them out and see how it looks. Let's start building mine a little bit. I built mine early, so I know where the coordinates land. Oop, I need to do that one differently. You should do a T-chart. Okay, there's that one. And this, and the other point is at, I got one at 5, and I got 1, 2 right there. And they are perpendicular. Nice. Yeah. So make sure you get your T-charts, make sure you get everything situated, and that should be perfect. All right, a couple things you're